Okay, so this video is probably going to be a long one, but basically we're going to be live coding the stuff I talked about in the last video, where we basically check the pass constraints up here, hopefully trying to improve like efficiency and whatnot. So yeah, if I this is obviously what we did last video. It took like 1 second to solve this board, and like 45 to solve the other one. I'm not going to run that now, it's just wasted time, but yeah, I'm going to try and get these numbers down a bit. In particular is 45. I don't mind if boards take a second to solve, but 45, especially this small of a board, can't be doing that. So first up, what we're going to do is we're going to change this. This isn't going to be an else anymore, it's going to be an elif, and it's going to be if we pass the constraints with the board, then you're allowed to progress basically. Now pass constraints is going to return true, and true is going to be the default that it will return, and basically it's going to return false if any of the criteria that we're about to code in get met. So I can just save this and we can run this, and this basically should be the exact same. We should still get a second to solve, we do. And we still get a correct board. Look, this is still a valid solution. So that's good, it works. So we're now calling this function and returning true. Okay, so the first method that I plan on adding to check, basically if we have a possible solution, is I plan on using this number of neighbours function and checking basically if you have like 3 neighbours the same as you, so 3 neighbours or 4 neighbours, then basically you're an invalid board and you're never going to be solved. So basically it's checking for loops. If we look at the board up here, it's checking for any cases like this, where like say this centerpiece right here is connected to down, left and right, so this would now be invalid. It's also checking for like say this red to make sure it doesn't do anything daft like this. So yeah, this will hopefully cut down on the number of boards we end up with. So yeah, let's get started on this one. So we're going to say so number of neighbours returns. So I've actually commented this a little bit to try and explain what each function does. So this one right here, it checks how many neighbours the xy square has of the same colour and returns it as an int. So this actually means really easy to code. We can just say if number of neighbours of the board in the okay, so we actually need to loop over the board, so we need to check the number of neighbours of every single square. So for I in range, is it numpy.shape or is it board.shape? Let's have a look, I'm sure I've used it somewhere else. Board.shape. So board.shape 0. So this is just a more rigorous way of using like the size of board thing that I used to use in the old code. For j in range board.shape. Now this can take in the length of the board, so in theory this could take in like boards that aren't 5x5, it could take in like a 5x6 and stuff. Not really interested in that, but it's just I may as well code it since it's no more extra effort. Now for each square we're going to say if number of neighbours, and our number of neighbours takes in 3 parameters. It takes in the board, it takes in the x, so the I, and it takes in the y, which is the j. Now if that returns a number greater than 2, then we can return false. We've hit something that is basically going to cause a problem, because we've now got more than 2 neighbours, we've got 3 or 4 neighbours. And that is it. Pretty sure that is it. Now let's just run it, see if we hit any errors, see what happens. Okay, so we're now getting a none, so we have hit errors, and I'm really hoping this isn't going to take long to fix, because I've had a ton of problems with this recursive bit right down here. So what I want to see is if we return a false down here, I'm going to print out the board. I want to see what board we actually returned a false with. So this board right here apparently has more than 2 neighbours for some of them, which doesn't seem to make sense. Pretty certain that's not actually the case, and I think it's... Does this number of neighbours function not work right? I'll print board and I'll print the I and the J so we know exactly what square it's saying has more than 2 neighbours. I know what it is. This might have been causing problems that I've had previously. So I think it's to do with so basically I'm encasing all these in try and accepts because I'm expecting index errors, and then when I hit these index errors, the reason I'm expecting index errors is because basically it's going to loop up to like 5 for x, and then it's going to say x plus 1, which is 6, so board 6, it's going to reference board 6, which it doesn't exist, it doesn't go up to that high of an index. Sorry, board 5 because it's 0 indexing, but yeah. But what I didn't account for was this -1. Now -1 doesn't actually index error, it doesn't hit an index error, it just loops back to the opposite side of the board. So what we need to do is say if x is greater than 0, then do this bit down here. And then we need to do the same for the y over here. If y is greater than 0, then do this bit. And I'm pretty sure I'm going to have done this in other places, like here for example, like possible moves here. This will be like saying that moves are possible through the wall and stuff. Wow, this is a huge error that I made. So if I is greater than 0, then check this, and if j is greater than 0, check this. Okay, now I reckon that the old code might also have some errors in like that. Possibly not. Yeah, I think it has the exact same error in right here. So I think I need if I is greater than 0. That's interesting because this error right here didn't actually cause any problems. But I'm pretty sure it would at some point. I just don't know when. So hopefully that fixes it. And now let's run this again. So 2-2 is now apparently got neighbours that it shouldn't. So okay, so this is the 0 one. It's in the 0 right here has more than 2 neighbours, which it does. It's got 3, obviously, because it's passing in these zeros. So all we need to do is just not check those. So where am I at? I need to be in this pass constraints. I need to say so characters that are ends. I basically need to just copy this in. And then if board ij is in characters that are ends, then we check this thing right here. So save that, run this, and awesome, it works, we get a solution. Now if I stop it printing out this, hopefully the solution is now quicker than it previously was. So it was 1 second before, it's now 1.4, so it's actually slower. But let's check if it's actually slower even on this other more complicated board. So it had like a, I think it was a 0 right here, and a lowercase b there, and a lowercase b there. I'm going to leave this at a run for like, I'll leave it a minute to run, and if it isn't solved in a minute, I'm going to assume that this method is terrible. So that actually worked extremely quick, 1.5 seconds. So this B, let me just run that again, make sure I save this. Yeah, 1.4 seconds. Okay, so how is that quicker than when the board was simple to solve? What is going on? Let's just double check this to make sure I didn't get an error. Okay, that's really weird. So the slightly more complicated board is actually quicker to solve. Okay, so what I'm going to do now is we're going to see, whoops, didn't mean to do that. We're going to see how much of a complicated board it can actually solve. So I'm just going to make it this complicated. I don't want to go too overkill and just have the computation take forever. Maybe I went a little too overkill. What I'm most interested in here is that it does actually find a solution and that solution is right. If it gets a wrong solution, I'll be really sad. And this could take forever, so let's just work on making this board a little bit easier to solve, seeing where we're at, see if it can solve that. So we'll make this a lowercase b now, so it's actually just one more gap than the one that took like 1.5 seconds. So this shouldn't take too long, I don't think. Just cancel that, save this. So that's 1.5 seconds. Now, why does it suddenly get insanely difficult when we add this one extra level in? Interesting. So the important thing is we actually got working with the previous target board, so like it was a bit easier than the one that we're currently trying, but it did work. So what I'm going to do is while this runs, we're going to work on adding a new check, a new constraints check. So am I actually? Is there any need? See, what I'm thinking is we could check how we would incorporate this recursive solver with the old code straight away, or I could keep improving the recursive solver and try and get it to actually solve a 5x5, which I think sounds better. I think I might do that. Make it all recursive solver 5x5. Yeah, let's try that. So let's add some more constraints. So what can we think of? We could do the group thing, but I don't know how computationally intensive that function is. So, and it's a little bit different as well to the way it currently works. Oh, it's actually solved it. Interesting. 108 seconds to solve that board, but it did solve it and it did get it right, so that's really impressive. I wonder what makes it take this huge jump. Like, it went from 1.5 to 1.48 to 1.42 to 1.5 to 108 just by turning a corner. Like, it must be something to do with the corner, I think, but not too sure. But yeah, I want to basically use this group method somehow, but this code's quite long and it loops over like a lot of times, so it's not ideal to be checking this constantly. But then again, if you check this and hit a false, I suppose it stops you having to generate all these different boards and loop over all these different boards to check stuff. So perhaps the trade-off's worth it, I'm not sure. Let's see if there's any simpler ones I can add. So, what sort of boards are definitely wrong? I think this might be the simplest one, the one that I've just been speaking about, because the other sorts are the kind of ones where like you have bottlenecks and stuff. So, for example, this green can't go down here because then there's only one path here for blue and red to get out of. But checking that would be a lot harder than just checking this group method thing that I have. So I think I might have to check this group method. Thing is, I don't even think I can just copy paste. Well, not copy paste, but I don't even think I can just import this function, because this function doesn't do exactly what I want it to do. It's slightly different. I could use a lot of the logic behind it though. What I might do is I'll end this video here. So we've actually got the recursive function working now, and I'm pretty sure if I ran this on like a completely empty board that it would eventually find an answer. It would just take an eternity. So yeah, so I'm going to end the video with the fact that we've got this working, and I'll have a think about what other constraints we can add in to try and improve this time. So yeah, that's going to be for this one. Thanks for watching. If you want to see the next ones, feel free to subscribe and like and all that good stuff. So yeah, thanks for watching. I'll see you in the next video.